Okay, so once again, thanks for staying back. Now the purpose of today's session, once again, is to run through, test yourself for normal distribution, and I will cover some bits of normal distributions that may or may not be covered within the lecture itself. Okay, so I'll just go through the key concepts so that when you do the tutorial, you feel a bit more confident. Okay, or when we speed through the tutorial, at least yeah, we can make some progress. And because I'm also losing out lessons, so I don't have much time to do this. So no choice to do this if you can. So with this, right? Okay, so let's take a look at the first the first concept for normal distribution. Okay, first concept for normal distribution, right? We need to talk about this concept called continuous random variable. Okay, this is the first concept. Now, this is a bit different from discrete random variable. So discrete random variable takes in whole number values, right? Or it takes in certain values, but it's countable. You can count them in some sense. Okay? For continuous random variable, right? You are taking fine numbers. For example, you are taking height, you are taking weight, right? You can go as fine as you want, and like you can go as detailed as you want, right? So because of that, right, all these falls under continuous random variable. So we just take any real number. Okay? So because of this, so the idea from continuous random variable, right, is an extension from the discrete random variable. Okay, so remember when we did our DRV, okay, remember when we did our DRV, right? Okay, maybe I should go here. Okay, when we did our DRV, right, it was something like this. Okay, it was something like this. So you get a table, right? You get a table of your X and the probability, right? Something like that, right? And then you will probably get a histogram of values, right? Something like that, right? Now for CRV, okay, for CRV, right? This one over here would change to a generic function, okay? Because it has to be a continuous function, right? And this histogram, right, what you will mainly see, right, would be like a graph. It can be a bell-shaped graph, or it can be a increasing graph, or it can be, yeah, or it can even be like a parabola kind of thing, right? So it depends on what kind of function that we're looking at. Okay. Now, then for expectation, right? Previously for DRV, okay. Now the expectation of x previously, right, was sum of x times fx, right? Oh, sorry, sum times x times the probability of this, right? Something like this. Now, then for CRV, right, how do you get the expectation? Okay, how do you sum over real numbers? You integrate. So technically, you just need to integrate. Okay, something like that. And now once again, right? Now do you need to do all these things or not? Technically, don't need for CRV. Okay. What I'm just telling you that actually the CRV is just an extension of your DRV. That's all. Okay. Can now but some things that you just need to take note are okay. Some things that you need to take note are your function is a probability density function, so that's why it's called PDF. Okay. Function is always positive because probability must be always positive. Then because when we are looking for for the probability previously, right? For example, we were looking for this particular probability for these two values, right? So in essence, we're adding up the rectangle area under the rectangular block. Okay, and because of that, for a continuous random variable, the probability is the area under the curve. Okay, so for normal distribution, right, the probability comes from area under the curve. And if you were to look, right, the probability between two values is just the definite integral between A and B. Okay, when x is equals to one particular value, the area of a straight fine line is equals to 0. So probability of a particular value for CRV is not that important over here. Usually we'll talk about range for continuous random variable. Okay. Then for greater will be from A to infinity. Then the total probability will be equals to 1 still. Okay. So this would be the general concept that you need to have at the background. Okay. Now, so going on to this, right? We have normal distribution. So what is a normal distribution? In physics or in math, right? Or geometry, right? Normal means perpendicular, right? Like normal vector, normal line to the curve, that kind of thing, right? Now, however, for these statistics, right? The normal simply just means normal life. Okay, so the normal distribution is like a reflection of normal life. Okay, so the thing is that you can roughly put everyone into a bell-shaped curve. Okay, for example, height, for example, IQ, for example, test scores, weight, and so on, right? You can plot them, and if you get a large enough sample, they will follow a bell-shaped curve. And this bell-shaped curve is what we call the normal distribution. Okay, so the curve is your probability density function over here. So this whole thing is the thing for the curve. Do we need to know how to operate this function? Thankfully, no. Okay, thank goodness for technology. Okay, you have your GC to work with you. Then I tell you how the ancient people work this out. Okay, now then the description of this normal distribution, right, would be X following a normal distribution over here. And the two inputs that we need is the mean and the variance. Okay, mean would be mu, variance would be sigma squared. Okay, so this is the notation that we have for the normal distribution. Okay, now some properties of the normal distribution. This graph is bell-shaped, symmetrical about the mean. So this is a symmetrical graph. Okay, if it's asymmetric, it will be another distribution already. Okay, can then for example, physics, you learn a degree of freedom, right? Your thermodynamics, right? Something like that. Got or not? Don't have, never mind. Okay, never mind. Okay, so yeah, that one is a bit skewed to one side one. Okay, chi-square also skewed to one side one. Okay, so that one will be another distribution. Okay, now for normal distribution, median and mode also happens at the line x equals to mu, which is the mean. So mean equals to median equals to mode. Okay, x-axis is a horizontal asymptote, and it follows all the properties of continuous random variable where the area of graph, area under the graph gives you the probability. Okay, so with this, right? Okay, so with this, right, let's take a look at how do we work with GC. Okay, now thankfully you have GC. So for example, given x follows the normal distribution of 2.5 and 0.78. So 2.5 is the mean, 0.78 is your what? Is your variance. Yes, thank you. Okay, so the probability of a particular value 2.8 is 0. Okay, this one as you know. Okay, now probability of x less than 2.5 and greater than 2.5. Okay, if you notice, right, what is this? This is the mean, right? Right, because it is symmetrical about the mean. So the area before the mean and the area after the mean must be the same, and they must be half. And so this is the first thing. Okay, so if you know that you're evaluating at the mean, before and after must be half. Okay, what happens if it's not at the mean? Okay, for example, sorry, this one still error. X less than 2.8, right? So even if it's equal or not equals to 2.8, sorry, this one 2.8, okay? Even though it's equal or not equal to 2.8, right? Okay, now the thing, it doesn't matter. Okay, so whether it equal or not doesn't matter, but for binomial, it matters. Okay, so something that you need to take note. Then how do you calculate this probability? It is actually, if you draw a bell-shaped curve over here, you draw a line at x equals to 2.8. The area before your 2.8 will give you the probability. So how do you find the area? You go to your second variable, then second variable to look at the distribution. then you key in normal CDF. The lower is negative E99, means negative infinity. Upper is 2.8. So from negative infinity until 2.8, the mean is here. Now, this one we key in the standard deviation. Be careful, huh? This one we key in the standard deviation. So we need to key in the square root of 0.78. Okay, so variance, once again, this is the mean, 2.5. 0.78 is the variance. And when you key in this normal CDF, you key in the standard deviation, the square root of 0.78. Once everything, you get 0.63295 and so on. Okay, so this is the first thing to take note. Okay, secondly, let's say if you're looking for the area after 2.3, okay, whether is it equal or not for normal distribution doesn't matter. So once again, this probability comes from the area after 2.3. So same thing, lower is 2.3, upper is infinity or E99. Okay, now where do you get the E? The E comes from here. Okay, the E is over here. Do you see my mouse? Over here. Okay, so you second and this button to toggle this E. Okay, and so you key in over here. Okay, now then key in everything. Once again, standard deviation, then 0.590. Okay, round up to 3 SF. Okay, next. Let's say if it's between 2.4 to 3.15, equal or not equal doesn't matter. The lower and upper you can put in 2.4 and 3.15 already. Okay, so very, very straightforward. Okay, this process will be extremely straightforward. Okay, so this is the forward process. Okay, finding the problem, given the details, you find your probability. Okay, next problem is given the probability. Now it's on this side. Given the probability, I want to find back the x or find back the unknown. Okay, so what do we do over here is same. The mean is 2.5, variance 0.78. So how do I reverse? So how does it look like? The probability where x is before k is equals to 0.25. So means that the area before k, right? This area over here is 0.25. Okay, now, so what I would like you to do, right, is that whenever you do this evaluation, right, you mentally you should have an image of what's going on. Okay, mentally you should prepare an image of think where is the area. Okay, so for this one over here, because the probability is less than half, so your k should be on the left side of the bell. Okay, then after that, you shape this area. This area will be 25% of 0.25. Okay, now we need to use the inverse normal function. Okay, so you go to the distribution, inverse normal, put in your area, put in your mean, put in your standard deviation. Now, this one over here is a left tail. So we key in left, and then you paste, and you'll be getting your value 1.90. So this k over here is 1.904. Okay? So this one rather straightforward. So this one rather straightforward. So now you know that there is a forward process and there's a backward process. Okay? Forward means I'm going to find the probability. Backward means given the probability, I'm going to find back my value. Okay? So with this, very quickly, let's go to page 14 of your notes. Let's look at word problem directly and solve directly. Okay, let's take a look at this directly. Okay, question 1. Okay, so a chocolate bar sold over the counter is normally distributed with mean 200 grams and standard deviation 5 grams. Okay, so means, okay, so defining our variable, I'm going to let x be the mass of a chocolate bar. Or let's say if you want to be more complete, right? The most complete answer is randomly selected chocolate bar. Okay? And this one, the units will matter a lot. Okay, now, so X now follows a normal distribution with mean 200 gram and standard deviation 5 gram. So standard deviation is 5 gram, the variance is 5 squared. Okay, so be careful when we write down the variance, we key into the calculator, we key in the standard deviation. Be careful. Okay, so part 1. Find the probability where the mass is not exceeding 210. Okay, so for this one over here, what do we key in? Now here we key in normal, not PDF. This is normal CDF. We're not looking at the density function, we're looking at the cumulative one. So what is the lower? The lower that you need to key in would be -1 E99. Okay, the upper one that you need to key in 210. Your mean is 200, standard deviation 5. Okay, so once you get this right, once you key in everything, this one would be 0.977. Okay, to 3 significant figures. Okay, now when you're doing this right, mentally what I want you to have, the image that I want you to have would be this. Okay, mentally the image that I want you to have will be, oh shoot. Okay, the image that I want you to have will be something like this. Okay, you have a normal distribution graph, normal graph, right? So your mean, right, is 200, right? But the value that you're looking at, right, is 210, like that, right? So the thing is, what is this area over here? Then this area will be 0.977. Okay, mentally, you should be having this image. Yeah, can. So this is the first one. Okay, second one. Okay, part 2. We want to look for the probability where X is not less than 185. Okay, so same thing for this one. We can evaluate the probability. So normal CDF, the lower value is 185. Don't have to write all these things. You just need to key in. Upper is E99. The mu is 200. The standard deviation is 5, right? So you don't have to write whatever red color, purple color that I write. Just write the blue color enough. Okay, red color is for you to key in. Can. Okay, so with this one, right, if you key in nicely, this is going to be 0.999. Okay, in the same way, the mental image should be like that. Draw the graph, right? Your mean is at 200. I'm taking 185, right? And I'm asking what is this whole area over here. So this whole area will be 0.99. Okay. Okay, part 3. Okay, part 3, part 4, I think I don't need to explain much. I think with these two examples, you roughly know what I'm trying to get at. So part 3, right, same thing, probability where X is at most 205. Straight away with your calculator, 0.841, 3 significant figures. Straight away, okay? Same for part 4, I'll be a bit lazy. Probability where X is at least 187. Press your calculator, 0.995 to 3 significant figures, okay? So the main thing that I want to go through is part 1, part 2. Part 3, part 4 is repeated, so I don't need to go through again. Okay? As long as you have the idea, I'm okay already. Now, let's take a look at number 2. Okay? Number 2, the marks in the promo exams are found to be approximately normally distributed with mean 60 and standard deviation 10. So for question 2 over here, same thing, I'm going to let X be the marks in the promo exam. Okay, so because of this, X follows a normal distribution of mean 60, standard deviation is 10, but usually when we write the distribution, we write the variance. Okay, be careful, we write the variance 10 squared. Okay, and this is approximately normal, so I'm going to put approximately. Okay, we will see this again soon, next chapter. Okay, Not for this chapter, next chapter, yes. Roughly, they give they wrote that approximately normally distributed in the question. Means it's going to be, okay, it's going to be like that lah. Then when you draw the graph, right, it will be something like this. Something like this. Like the usual normal the usual graph that we see after WA, right, is going to be like that. Yeah. Okay, approximately normally distributed. Okay, so okay, let's take a look at this one. If 10% of the candidates were awarded grade A, what is the least mark for A? Now, so this one, right, let's take a look. The mental image that I would like you to have is, okay, from this normal graph, okay, from this normal graph, right, 10%. Where is the A people? Usually on the left or on the right? On the right, so on the right, 10%, right, would be a very small area over here. So this area here is going to house 10% of the people, right? And they're asking for what is this marks over here? What is M? Okay, can. So then if you want to put in more details, your mean over here is 60. So definitely if your answer is less than 60, something is wrong. Okay, can. Okay, so with this, let's take a look at how do we do this. So given that probability where x is greater than this mark would be equals to 0.10. So what should we do? Now we are looking for the unknown. We are not looking for the probability, but we are looking for the unknown. Okay, so we use inverse normal, correct? So for this one over here, we need to key in inverse normal. Okay, so what is the area? Area is 0.10. The mean is 200. Standard deviation 5. For this one over here, what tail is this? Is a right tail, right? So this one, you use your right tail like that. Okay, so because of this, right, from GC, your M is going to be just equals to 72.8, just like that. So you don't need to write so much. You just need to write these two lines here. As in, these two to declare your variable, and one line given, and then the next line is just from GC already. It's very, very fast. Okay, so once again, for normal distribution, the working is extremely fast. Okay, you can get your answers pretty fast already. Okay. Wait, sorry. Do you need this? Okay, so question 1 is forward, question 2 is backwards. Okay, now let's take a look at some of the other backwards kind of question. Yeah. So what are some of the backwards kind of question, right? Would be something like this. Okay. Let's say, okay. If more than, then we use the right tail. Now, if it is center, if you use your calculator, right, you notice that there will be a center, right? So what does the center do is that given this area over here, you already know this probability, right? If you use the center, it will give you the two values symmetrically from the mean. That will give you the area. Okay, one more time. The value that it output will give you the two values which is symmetrical from the mean. So these two values, right, it will be equidistant from the mean. Okay, if you use the center. Okay, so center, right, it has to be symmetric. Okay, can. So what if it is not center? Then what do? You will need to consider the first area minus the second area. Okay, like that. Okay, so example. Okay, example. Okay, so if let's say if it's not symmetrical, right? Okay, can okay, let's take a look. Now, if let's say if it's not symmetrical, right, and this area over here, right, it is 0.83. Okay, so what are some of the things that you can do? Now, if you take a look, right, you can take this big area, which is over here, right, minus of this small area over here, right? So technically speaking, you can do something like, yo, why you keep? Okay, so technically, right, you can do something like this. Probability where x, sorry. Okay, probability where it is in between A and B, right, would be equals to probability where x is greater than A minus probability where x is greater than B. Okay, so meaning I'm looking at this minus of this small part over here, like that. Okay, this is A, this is B, right? Something like that, right? Okay, next, or you can also even write as probability where x is less than B minus probability where x is less than A. Also can. Okay, can yeah, correct. Something like integration. Okay, finding the area under curve, that idea. Okay, can okay, now, so with this, right? Okay. So with this one, right, let's take a look at one more last kind of reverse problem. Okay, which is your tutorial section A, right? Your question 3 and so on. I think no, question 1, but or question 2. Okay, so this one, right, is like that. Now, instead of an equal sign, right, I'm looking for the probability where it is less than 0.25. Now it is an inequality. So what should we do? For equal sign, it will be very direct because equal sign, right, when you use inverse normal, it will give us the unknown value. But when it is an inequality, right, what should we do? So the first thing that we should do is we will need to treat it as equal first. Assume that this is equal, we find our value k first over here, 1.9. Okay? Can one more time? We assume that this is equal, and the unknown that we found at the end of the day, this k is going to be 1.9. Okay, next thing to ask yourself, the next question is, now the area is slightly less than 0.25 or less than 0.25, right? So this means, right, the shading must be on the left-hand side of this k. So this also tells me that the A that corresponds to this area, this unknown A, must be less than k lah. Okay? So when you're doing inequalities, right, it will do you good if you can do a soft sketch of k and your A. Okay? Then you can analyze and see that actually A is less than k. Okay, I'll repeat the same thing, but for the other case. Now, okay, this probability is greater than 0.25. First step, I'm going to assume that it is equal to 0.25 first. So when it is equal to 0.25, the k is 0.25. Sorry, the k is 1.9 when you do inverse normal. So the second question that you want to ask is, when this area is slightly greater than 0.25, so this means that I need to shade a little bit more than the area for k over here, right? When I shade a little bit more, the corresponding A is on the right hand side. So this is why A must be greater than this 1.9. Okay? Can So hopefully this will help you with your section question 2 part C, part D, something like that. Okay? And once again, I would like to highlight that inequality for normal probability, right, is rare, but it will still come up. It's rare, but it will still come up. So you keep your toes open. Keep your toes open. Keep your toes on. Keep your eyes peeled up. Yeah, whatever. Yeah. Okay, be on your toes. Yes, thank you. That's why I teach math, but not English. Okay. Okay. Now, next one. Next concept. Okay, next concept. We will proceed on from the usual normal distribution, right? So we will go through a process to, okay, to standardize the normal distribution. Okay, why? Two reasons. The first reason is usually when we have many different normal distribution, right? For example, even in school, you have math, you have chemistry, you have physics, you have biology, and so on, right? So the thing is that when you want to compare performance, right, it will be good to compare to a standardized performance. So what do we do is we would transform the mean and the variance of the original bell to become 0 and 1. So from the original mean and this variance, right, we will standardize to become mean equals to 0 and variance equals to 1. Okay, so this means that originally you have this random mu over here, something like that, okay, with a certain standard deviation, right? When you standardize, okay, when you standardize already, it will be like something like that. Okay, now it will be centered at 0 and the variance over here is 1. Okay, and with this, right, you can make a lot of comparisons. Okay, now, and the reason why we want to make this kind of comparison, right, is that so that people of the ancient times can evaluate the probability. Yeah. So now with GC, we technically don't really need to standardize anymore, but we standardized last time is to make all the different normal distribution to be standardized so that we can use a probability table to evaluate the probabilities. But with GC, there's no need, right? So what is the next motivation to standardize is because sometimes we have unknown mean and unknown variance. Okay? Sometimes our mean and variance over here are unknown. So when do we now standardize is when the mean and variance are unknown, then we standardize to find the mean and the variance. Okay? Can? So this one is extremely important. So if I were to ask you, when the mean and variance are known, what do? You need to standardize. Okay? Now only two people say, right? But after this, everyone must say together with confidence. Standardize. Say thank you. Okay. Yes. Okay. Now, so let's take a look at what do we mean by standardizing. Okay, over here. Okay, page 21. Now, the speed of cars passing a certain point of motorway can be taken to be normally distributed. So the quantity would be x. Let x be the random variable denoting the speed of cars in kilometer per hour. Okay, kilometer per hour. Okay, so with this, right, x follows a normal distribution. I don't know the mean, I don't know the variance. So I have to standardize later. Okay, now observations show that this phrase over here, 5% traveling more than 85%, right? So given that when x is greater than 85, the probability is 0.05, right? And at the same time, when it is less than 55, the probability is 0.10. Okay? Can okay, so there's no unknown over here. Right? What else do? We are supposed to find the unknown mean and the unknown standard deviation, right? So because of that, we need to standardize. Okay, how do we standardize? We make use of this formula Z. Okay, this Z equals to x minus mu over standard deviation. Okay, Z equals to this. So we make use of this formula. Okay, and because of this, right, we can change this to become Z, and this Z follows a normal distribution of 0 and 1. And so this is standardizing. Okay, so how do we do this? How do we do this? So probability, straight away we put the z. So what do we do with this 85? 85 minus the mean over standard deviation. Okay, 21. 21. Got 21? Yeah. So this one, the probability will still stay the same. Okay, now let's standardize the other side also. Okay, so when we standardize z, right, the inequality still stay the same. 55 still stay the same, but we need to change this to minus the mean over your standard deviation over here. Okay, so this one will be equals to 0.10. Okay, next. What do you do? We find the unknown, right? Let's find the unknown for this one. Okay, so we key in the inverse normal, right? So the area that we are looking for is 0.05. H. Important, what is the mean for this one? Now we already standardized to the standard one. So now the mean is 0. The standard deviation is 1. Okay, and this is because of this one, this is a right tail. Okay, and so with this, you key in okay, so this one, your unknown 85 minus mu over this would be equals to 1.644854. Okay? And so this will be equation 1. Okay? Next. The next one over here, using the same inverse norm. Okay, your unknown 55 minus mu over this will be equals to negative 1.281552. Okay, so this one over here is equation 2. So it's like throw away the probability function or throw away your tangent, throw away your sign, right? Throw away this function to reveal what is the input. Okay, it's like an inverse function. Okay, now because of this, the next step, right, you don't need to do the hard work. You just use your GC to solve 1 and 2. So your mean would be equals to 68.14. Your standard deviation would be equal to 10.25, which is roughly 10.3. Okay, so this is part 1. And now, part 2. Okay, in case you are not sure what to key in for this one over here, okay, inverse normal. Area is 0.1, mu is 0, standard deviation 1. This is your left tail inverse. Okay, next, part 2. If at a certain time interval 500 cars pass through the point, expected number of cars that travel at more than 70 km per hour during that time. So probability where this x is greater than 70 km. Now we've already got our data already, right? So we can make use of your normal CDF to evaluate this probability. So your lower is going to be 70. Your upper is going to be E99. Your this mean is going to be 68.14. Your standard deviation is going to be 10.25, as accurately as possible. Okay, then you will get something like Okay, so this one will be roughly 0.4280019. So expected number of cars would be 500 times this value over here. Would be around 214.0009, roughly 214 to three significant figures or round to the nearest integer. Okay? Yeah. Comparing the two. Okay, can. Can, no problem. Okay, can now, while you are writing this down, right? Okay, let me also draw an example just now. Okay, so this was the one given in the summary sheet that I typed out. Okay, so this one over here, right, is the example over here. Now, with standardization, right, how do I find out the probability last time, right? For example, x greater than maybe x greater than 3.1 now. Okay, something like that. Right? Okay, so what do I do, right, would be, so in order for me to evaluate this nicely, right? Okay, what the international people and what other ASEAN countries do, right? They will make use of this probability table. Okay, so they will need to standardize this first. Okay, so how they standardize would be 3.1, okay, minus away the mean, minus away or divide by the standard deviation. Okay, so means that they are looking for this particular value over here, z greater than 3.1 minus 2.5 divide by square root of 7.8. Okay, so this one will be 0.214834 like that. Okay, now, so with this value, right, how would they calculate this? Would be, okay, they will look at this table. So last time when I didn't have GC, right, what I do is I look at this table. So I look at this table. Yeah. So what's the value just now? 0.214834, right? Okay, so what I do, right, is I look for, yeah, 0.214 all the way here, right? So 0.5832 plus 15. So 0.5847. Okay, something like that from the table, right? So this is what the international students do with standardization. So every probability they need to standardize because they don't have GC to work with, but they use the table to do this. Or now even worse, right? Now, right, 5847, right? How do I find back the original value? Even worse. So I need to find 58 something, right? Right? 58 and this, right? So I need to find from here, I need to find 0.221 something. Yeah. Okay, so the inverse process, right, is really by the table. So you really have to thank Singapore for allowing GC in your exams. Okay. Now the part about comparing two different variables, right, is that once you can gauge, once you can get your two different quantities to standardize already, right, it will be easier to look at the top 10 percentile, your top 20 percentile, and so on, because you can just calculate the probability of your 0.1 from the right, that kind of thing. Or you can calculate where is the, like, you can see, right, roughly, you can roughly see, right, because all standardized already, right? So you can compare and see for a certain card, right? Then Because you already know the probability, right? So you can work backwards to find the values that you need, that kind of thing. Okay? Can. So the thing is that, yeah, for our syllabus, right, there's not much value to standardize because everything can be done here. We can straight away convert things and back calculate with our GC already. Okay? So there's no point to compare two different quantities because we can compare straight away already. But the thing for our syllabus, the main thing is if the mean and the variance, right, are unknown, then we have to standardize. Okay, can. So this would be concept number 2, standardizing your to the standard normal distribution. Okay, can. So yeah, yeah. I think this one is just example. Yeah. So what does the international people do, right? They from X, right? They must convert to Z first before they calculate the probability. Okay, something like that. Hey, actually no leh. Greater than, right? Actually no leh. It's actually 1 minus leh. 1 minus this leh. Yeah. 1 minus this because the table is left. Yeah. Yeah. Can. So okay, just some idea for you lah. Okay. Now moving on. So that was concept number 2. Okay. Now the reason why I wanted to do this, right, is because of the next concept over here. Okay. Now if you don't know your basics, right, it will be very hard to do the next thing. Where is my mouse? Okay. So I will need to look at the next thing. Okay. So the next thing is over here. Okay. Okay. Now this one, right, would be the most important part in this chapter. Okay, the most important part in this chapter, especially the one below here. Okay, this next part that will come in. Okay, can. Now, so once more, what we did previously, how to evaluate probability, normal CDF, how to find the inverse, inverse normal, then we standardize to when we have unknown mean and variance. This third concept is on the linear combination of random variable. So when you have multiple of random variable and you want to add all the random variables together, this one follow the concept from DRV. For example, what happens to the mean when you have AX plus BY plus C? What happens? It will be just A times of the mean of X plus B times of mean of Y plus or minus your C, right? Plus minus plus minus. So this one very straightforward. The mean is always very straightforward. Okay, so whatever changes, multiple or sums that you add to the mean, right, you just do together, follow the instruction. But when we come to the variance, we need to be careful. Okay, now I've mentioned before, variance of when you add two quantities together, right, the error must add, right? So the variance must always plus. Okay, then because you multiply, right? Okay, because when you multiply, your standard deviation is times A. So when you square your standard deviation, your A will also square. So this becomes A squared for the variance. Likewise, for B, whether is it positive or negative, when you square, it becomes a positive B squared. And the variance of a constant number is 0. So because of that, it will just be A squared variance X plus B squared variance Y. That's all. Okay, so this one, just be very careful. So when you're doing the calculation, right, you can calculate one by one. You can calculate the expectation and variance separately, or you can do you can combine all the calculation into this step over here. Okay, so this is the first thing that you need to take note for this part. And now, one thing, the next most important thing to take note is you need to distinguish between your multiple and sums of X. For example, if this is n times of X, what happens to the mean? What happens to the variance? So this one over here, the mean just times n as usual. The variance, right, because this is a multiple, so standard deviation you times n, variance you square, so it becomes n squared of the variance. Okay, so this one is the multiple of x. However, when you have the sum of x, for example, x1 plus x2 until xn, where it is a repeated copy of x, the mean also times n because it is n copies of the mean, but the variance, right, is also n copies of the variance. So this is why when you have sums of x, the variance just times n, because it's just variance 1 plus variance 2 plus variance 3 plus variance 4 all the way to the nth variance. Total will be n times of the original variance. Okay, so the distinguishing factor, right, is this n square and n. Okay, so before we head to this, let's quickly look at page 24 first. Okay, 24. Let's do some calculation. Okay, now you have many ways to do this. Okay, we have definitely have many ways to do this. So the first thing that we'll take a look, right, is this. We are looking for x plus y, right? So we are given these two quantities over here. So let's combine them. So sums and multiples of normal distribution will still be normally distributed. Okay, so we need to figure out what is the mean of x plus y and the variance of x plus y. Okay, cannot. So this is part one. Okay, so this one over here would be the mean of x plus the mean of y. So this would be 100 plus 110, so 210 over here. Now, variance, right, would be variance of x plus variance of y. So this would be 49 plus 576. So this one would be 625. Okay, you can do something like that. So because of this, your x plus y now follows a normal distribution of 210 and 625. Okay, so this is the first kind of presentation. The second kind of presentation is if you are lazy and if you want to do things fast, you can straight away x plus y follows a normal distribution. Now, what happens to the mean? 110 plus 100 plus 110, and then 49 plus 576. So because there's no equal sign, so usually I will just copy this whole thing. There's no equal sign. Okay, so we cannot put equal sign. Remember, I have to rewrite the whole thing like that. Then simplify to 210, 625. Okay, can now let me tell you something first. So technically, like whatever that you do, regardless is it long or short method, right? It doesn't matter because no marks. Where is the marks allocated? Usually how I mark or how the teachers will mark would be this one 1 mark, this one mark, then the probability 1 mark like that. Okay. So usually we will spot 210, 625 and the last probability. Easier to mark. Okay. So whatever working that you have in the middle, right? Because there's many ways to show the working, right? We are a bit lazy to see lah. So we just look at these two crucial values for you. Okay, so on your end, whether do you want to do slowly and carefully, or do you want to do fast, is entirely up to you. There's merits to both working. That one is fast, but it will look super confusing on the right hand side. The one on the left hand side looks very clear, but it takes a lot of time to really write it out. Okay, can so you just try to find the balance. If you want to do the left hand side, right, find the balance. Which one do you don't want to write? For example, the one in the middle, maybe don't need to write, right? You can just write 110 plus 100, that kind of thing. Okay? Cannot? Something like that. Okay, so with this, right? Okay, so with this, straight away, you can key in your calculator already. So your probability of x plus y greater than 200 will be equals to, straight away, you will get 0.655 straight away. Okay, once again, you key in your normal CDF. Okay, your lower is 200. Your upper is E99. Now, mean you put 210. Okay, standard deviation, be careful, be extremely careful. square root of 625. Okay, super careful. Okay, next, part 2. We are looking for y minus x. So because of this, okay, if you were to do the slow way, expectation of y minus x would be ey minus ex. So this one would be 110 minus 100. So this is just 10. Okay, variance of y minus x is equals to variance of y, variance of x, right? But we minus. Be careful, sorry, we plus. Variance always plus. Okay, so because of this would be 49 plus 576 equals to 625. And because of that, y minus x follows a normal distribution of 10 and 625. Okay, so the probability between negative 20 and 50 would be 0.830 like that. Okay, so the troublesome things for normal distribution is the setup is very long, but the working is very short. The official working down there very short. Okay, but the setup takes time. Either you express this way or you express that way also can. Okay, it doesn't really matter. Okay, now last one for this section. Y minus x. Okay, so part 3. Probability of modulus y minus x minus 5 modulus greater than 4. Okay, now what do we need to do is we need to open up this modulus sign, right? So recap for your modulus function. When x modulus x greater than 4, what happens? It is either x more than 4 or x less than negative 4, right? Then the second thing to recap is modulus x less than 4, what happens? It will open up to negative 4 less than x less than 4. So x is in between these two numbers. Okay, so these two results we need to use very fast. Okay, so because of this, this will be equals to probability of this whole thing more than 4. All means plus the probability of this whole thing less than negative 4. Then you just put in, throw the 5 to the other side. Then you throw the 5 to the other side. Okay, now then you just need to add two separate normal CDFs together. Okay, and then you get 0.875 like that. Okay, just that the lower and upper different. Okay, you can use the same mu and your sigma. Okay. So once again, when it comes to modulus, don't worry. Open the modulus, throw the rest to the other side. Keep your variables on one side. Okay. Okay. Last but not least. Okay, the last section already. I think we can finish in time. Yeah. Last section already. Can Okay. Can. The final part is the difference between multiple and sums. Okay. So let's take a look at these two examples over here. Now, first one. Weight of a piece of chocolate produced by a factory is normally distributed, okay, with the mean and variance like that. Okay? So mean and standard deviation like that. Now, we want the total weight of 3 pieces of chocolate. Okay? And because of that, right, the total weight over here is x1 plus x2 plus x3. Can. So because we are looking for the total weight, right? Now this y will be equals to x1 plus x2 plus x3. Okay? And because of that, when you do the mean and variance, right? The variance just times 3. Be careful, huh? Then when it comes to the price of a chocolate, okay, the selling price is 3 per gram, right? So when it comes to the price of a piece of chocolate, it becomes 3 times x because it's $3 times x, right? And because of that, the variance over here need to square, 3 squared. Okay? So you need to be very careful with sums and multiples. And the next level problem is that usually for normal distribution, one for sum, one for multiple, and the next level problem is combine both together, sum and multiple together. Okay, so that one you'll see in the later parts of your normal distribution. Okay, the last few questions. Right, so back to this one over here. Let's go to page 28. Last one already. Now, last one already, yeah. Okay, so soft drinks manufacturer and so on. Okay, so let's declare. Okay, if you read carefully, so you can let x and y be amount of soft drink in small and large bottle, because we write two together, right, respectively. Okay, in milliliter. The unit, be careful, sometimes you need to convert one, be careful. Okay, so x follows a normal distribution of mean 2, 5, 2. Variance is 4, be careful. And y follows a normal distribution 1, 0, 1, 2. Variance is 25. Okay, a bottle of each size is selected at random. Find the probability that, okay, over here you see that the large bottle is less than 4 times the amount of the small bottle. Can you see this? Y less than 4x, right? So the inequality that you can write would be y less than 4x. Then this makes us write out y minus 4x will be less than 0. So this is the one that we need to calculate later. Okay? Can. Okay, so let's try. Okay, so we need our y minus 4x. Okay, so you want to do fast, you want to do slow, up to you. Can. So I will take y minus 4x. Okay, so if you want to do slow, okay, slow and steady, expectation of y minus 4x will be equals to expectation of y minus 4 times expectation of x. So this is going to be 1012 minus 4 times 252. So this one will be equals to 4. Okay, next one. Variance of y minus 4x would be the variance of y, be careful, plus 4 squared of the variance of x. Okay, so this one would be 25 plus 4 squared times 4. So this one will give us 89. Okay, and because of that, y minus 4x follows a normal distribution of mean 4 variance 89. Okay, be extremely careful. Okay. Now, so with this probability where y is less than 4 times of x will be equals to probability where y minus 4x less than 0. So this one, just use your normal CDF, you will be able to get 0.336. Can. Normal CDF. Okay, last one. No, say second last one. Okay, 4 small bottles are selected at random. Find the probability that the amount in the large bottle, so the amount in the large bottle is less than the total amount in the 4 small bottles. So this one is the sum of amount in the 4 smaller bottles, right? And sum of amounts in the 4 smaller bottles. So because of that, you can foresee that you will need the expectation of y minus x1 minus x2 minus x3 minus x4, right? Something like that. So this one is just expectation of y minus, okay, if you want, you can bracket them and put the pluses together, 4 times of ex. Okay, so same thing, this will be equals to 4, like just now. So this one don't need to write so much. Okay, the variance one is the one that I need to show you. So variance of y minus x1 all the way to x4 would be variance of y. Okay, so this one, be careful. This one become plus 4 copies of variance of x. So this one would be 25 plus 4 copies of 4. So this one will be equals to 41. So therefore, y minus x1 minus x2 minus x3 minus x4 follows a normal distribution of 4 and 41. Okay, and also this is doing very slowly lah. If you want to do fast in a compact manner, can. Okay? Then but ultimately show clearly that it's 4 and 41. And okay, so with this, your probability for y less than x1, x2, x3, x4 will be equals to probability of y minus x1 minus x2 minus x3 minus x4 less than 0. This one you use normal CDF again, 0.266. Okay, last one. Last exercise. So find the probability that the total amount in 4 large bottles exceeds the total amount in 8 small bottles by at least 200 ml. Okay, so let's see. So for total amount in 4 large bottles. So this is a sum, not a multiple. Because the keyword over here is total. Okay, total means we add things up. Exceeds 8 small bottles by at least 200 ml, like that. So this is the one that we're looking for. So what we're looking for is y1 to y4 minus x1 to x8. Okay? Now, so how are we going to write this out? Okay, part 3. So y1 plus expectation first. Okay, expectation of y1 all the way to y4 minus x1 all the way to x8. Okay, so this one would be 4 copies of EY minus 8 copies of EX. Okay, so 4 copies of 1012 minus 8 copies of 252. So this one will be 2032. Okay, next one. Now the variance of y1 all the way to y4 minus x1 all the way to x8. So this one would be 4 copies of variance y. Be careful. Plus 8 copies of variance x. Okay, so this one would be 4 copies of 25 plus 8 copies of 4. Be very careful. So this one will be 132. Okay, so the probability where we get y1 all the way to y4 less than x1 to x8 plus 200. This one is going to be equals to y1 all the way to y4 minus x1 all the way to x8. less than 2,000. Okay, this one using your normal CDF, you should be getting 0.997. Okay, like that. Uh, okay, whatever. Okay, never mind. I give up. Give up. Okay, can. Something like that lah. Okay. Can okay, so this exercise, this particular question over here, right, wants you to distinguish between multiples and sums of x. Okay, so when you're looking for the mean and variance, the variance is the one that it will be very, very confusing. Can okay, so I wanted to go through tutorial section B lah, but I think it's okay lah. It's okay. I wanted to, but since we took some time to get here, yeah, okay, so we can call this a day. So you get ready lah. 06 you get ready tomorrow, 20 you get ready next week. Can next week we have to go very fast already because I want to finish this fast before NWA. Okay. Can.